Hello, this particular episode is about skewed tables and histograms related to skewed tables. So we're actually going to create some histograms today and see how they react with some data that is skewed. So the first thing I want to do is create a skewed table. So let's do that. Let's take a look at, I created a two-column table, one called all distinct, which is based on the row numbers, and one called skewed. So all the data right now is one value, but I'm going to fix that. And I want to create an index on that column, on the skewed column. And let's take a look at, once I've done that, let's take a look at the data distribution on skew. Okay, so there's 10 values that have a unique number, and then a whole bunch that don't, that have this number 10,000. Okay, let's do some gather stats on this table, but let's make sure that there's no histograms created. And how to do that is we say for all column size 1. So let's set our NLS date format and our line size. And let's check out our histogram, what histograms are created. Okay, so we have two columns. The first column doesn't have a histogram, or neither column have a histogram because I've chosen for all columns size 1. Okay, so now let's do an explain plan for select using the 10,000, and let's look at the explain plan for it, for this particular query. Note that when we run explain plan 4, it actually doesn't save the query in the shared pool. Okay, so when we run this, we get a index range scan because it thinks that the data is distributed perfectly on the column skew, and there's an index for it, so it's going to use it, even though that's probably inappropriate. So let's do this again. This time we're going to create some histograms. And what I did here is I said for all column size skew only. So now let's query DB8 tab call statistics. And in this particular case now, I have the skewed column has a frequency histogram. Frequency histogram. There's 11 distinct numbers. So now let's see what happens when we run our queries. Let's see what's the explain plan for this particular query. And we do a full table scan. Let's see what happens when we use a value that's unique. And now we use an index scan. So that's great. Again, for our little test here, I used explain plan 4, so nothing got saved in the shared pool. But if we are running these queries for real, and we're using literals here, we'd be building up a bunch of queries that look very similar, but it could theoretically fill up our shared pool. So a better idea is to use bind variables. When you do that, the bind beaking will take place, and we have something called adaptive cursor sharing. So I wanted to show how that works. In this particular case, I'm going to create a bind variable. I'm going to populate that bind variable. Excuse me, and let's validate what it's done. Okay, so now I'm going to run my query, and notice I'm not doing explain plan 4. I want these to be saved in the shared pool. Okay, so let's look at our explain plan. Notice a a SQL ID is created because we're actually putting it into the shared pool, and we do a full table scan. Now, let's set it to 1, our bind variable to 1, and validate. And let's run the query. Now, the first time around, there's not going to be any change. It's still going to use a full table scan. But the second time around, it will create a child cursor. So let's take a look at that. And we can see a child cursor has got created, and it uses an index. Let's go back. Look now. Oops. Where is? Oh yeah, here's the query. And we can see a new child query gets created with bind peaking, and a full table scan gets created. Now let's go back and forth. So we did 1000. Let's go back now and see what happens. Those child cursors are saved, so now it knows for this particular bind variable to use child cursor number 1, and for this value of the bind cursor, bind value, bind variable, it will use child cursor number 2. And that's it for this particular video. So in this particular episode, I want to look at multi-column statistics. So as a general rule, your columns in your table need to be independent of each other. They need to be fully functionally dependent on the primary key, the whole key, and nothing but the key. That two columns shouldn't be dependent on each other, but in reality we know that that doesn't happen, and in particular we know that city, state, zip, and countries, those kind of columns have interdependencies. And I just want to show you what we can do to set up statistics based on a joint number of columns or a group number of columns. We call this multi-column statistics. So the first thing I want to do is some housekeeping. So the first thing I want to do is take the customer table and make sure there's no histograms taken. Okay, so the next thing I want to do is I want to run a query. In this particular query, I'm running just counting the number of customers where they're in California and in this particular country. And let's look at the cursor, or the explain plan. So the count is 3,341, but when we run the explain plan, it's assuming those columns are independent of each other and well distributed, and that's not the case. So it's assuming there's going to be 383 columns, but in fact there are 3,000 columns. So that's a very poor, that's a disconnect there, and it couldn't the Oracle SQL engine couldn't make intelligent decisions on whether to use an index or not use an index based on these counts. So what we're going to do now is we're going to set up some histograms based on a joint column. So let's look at this. So in this particular case, I said for all columns size 1, but in particular for columns country ID, country, state, province, we're going to say size skew only. What this does is it already creates an extension for us, a statistical extension based on country ID and state, province. We can do that independently. We can go into Dbms stats and create an extension and then do the statistics. But if you do this first, it creates the extension for you automatically. And let me show you some things relate to that. So my line size and my endless date format. And we can see that an extension was created based on country ID and state province, and it's given this name. This is the column name, and let's just take a look at it. So let's look at DBA calls, and we can see that this is a hidden column and a virtual column. It's based on the country ID and state province. And now let's look at the histogram, since we created some histograms based on that. Let's take a look. Okay, so this is all of the columns. Let's run it again. And we can see that this particular column, this joint column, now has a frequency-based histogram, and there are 145 distinct values of the country and the state. Because it's a both a hidden column, which I think I showed before. Did I show that? Yes, it's both a hidden column and a virtual column. We can rerun this particular statistics again, gather statistics, and we can say for all hidden columns, size skew only. And when I do, let's just make sure that that takes care of that. Notice what happens. Okay, so when we do that, we can see that we just updated just this column because it's a hidden column. So we just analyzed that particular column. So no change in the actual statistics, but I just wanted to show you that when you say for all, when you run for all hidden columns, it will just do those. That's great. Now let's see what happens when we run our query. Okay, so the query returns the same number of rows, but now let's take a look at what our cursor says, or our explain plan. Now the expectation of number of rows is more accurate, and so now the Oracle SQL engine can make better decisions when it comes to indexing. Let's do a different example. When you take Vermont this time, there's only 33 rows. And let's see what the cursor or the explain plan says for this. Again, based on the statistics, it has better information now, so we can expect that there's 33 rows, which corresponds to what we're expecting here. So now again, the SQL engine can make better decisions. So in many cases, or not in many cases, but in some cases where you have columns that have interdependencies with each other, it's a good idea to create an extension based on those joint number of columns. And the best way to set this up is just to go ahead and run Dbms stats on the, using the syntax I showed earlier at the very beginning, where we say for columns, and we indicate the number of columns here, and say size skew only. So what happens is we create the extension and the histogram all in one shot. And that's it for this particular discussion. So in this little episode, we're going to do some examples with virtual columns and histograms. I'm going to create a table, create a virtual column, put indexes on those columns, and actually gather statistics on those columns and what have you. So I just wanted to do some exercises with that. So the first thing I'm going to do is create a table, and create a table of 70,000 rows. And let's just take a look and just verify that it's 70,000 rows. And then let's describe it. So this particular table has two columns in it currently, and one is a distinct number of rows from 1 to 70,000, and one is a row string, which I will show you sort of what it looks like. Let's just look at the first 20 rows. Okay, so the row distinct is a unique number from 1 to 70,000. The row string is a number from 1 to 10, and it's variable where it is in the string. So there could be a variable number of spaces ahead and behind the number. So I'm going to use this because I'm actually going to create a virtual column that does some substringing on this. So, in fact, what it's going to look like is something like this. Fix that. Let's run it again. Here we go. Okay, so this particular query I just did here actually does the substring and converts this to a number, or it doesn't actually convert it to a number, but at least removes all the extraneous spaces. Okay, so let's see how many bytes this particular table is. It is this number of bytes. Why I'm doing this is because now I'm actually going to create the virtual column. And I wanted to prove that the virtual column actually takes no space. So it's not a literal column, but a virtual one. And sure enough, it is. Now let's do another describe. So now we have 3 columns, and one is this virtual column that let's do this too. So apparently that doesn't do anything there. So okay, well, so what we've shown so far is that when we create the virtual column, it does nothing to increase the size of the table, which is expected. Let's see if there's extensions that are created. And sure enough, there is. So the virtual column actually creates an extension in Dbms, DBA stat extensions. Let's look at DBA tab calls also. So in this case, the virtual column is not hidden, but it is a virtual column. In some other episode, we created some multi-column statistics and showed that the columns were both hidden and virtual. So why that's important is that when you run Dbms stats, you can say in their method ops, you can say to do stuff with the hidden column as well. In this case, the virtual column is not a hidden column. In the case of multi-column statistics, it is a hidden column. So okay, so now let's create a an index on it. Let's gather table stats, and we for this guy, we said for all column size 1, so there's no histograms except for the virtual column. So notice that I can actually specify the virtual column here. Let's go ahead and set our NLS date format. And now we're looking at the DBA tab call statistics, and we can see that for all the columns we have no histograms with the exception of the virtual columns, which is now a frequency-based histogram. Let's go ahead and run our query. And let's look at our explain plan. Notice that this particular explain plan now uses the index on that virtual column. Something else I wanted to show was that earlier I had created the table and then did an alter table to add that particular virtual column. But we can do it all in one shot, and I just wanted to show a few things about that. So let's go ahead and drop our table. I'm going to recreate it, and in this case see that I've created the virtual column within the create statement itself. So let's go ahead and create that. Let's describe it. Okay, so now we've gone ahead and created the table all in one shot rather than just altering it. And we can go ahead and populate it as well. And this is the tricky part, because if I had tried to insert the data into the table with the default not specifying the number of columns, it will say there's not enough rows because it's expecting data to be put into this virtual column, which you cannot do. If you try to, you'll get an error. And so the only way to do an insert is to actually specify the columns you're inserting on, which is, in this case, this is the first two. And the third one gets populated because it's just a SQL. So let's go ahead and do that. Let's commit it. And now let's do okay. So now notice that this particular syntax here is required, otherwise we'll get not enough values or we'll get other errors. So you actually have to specify all the columns except for the virtual column when you do an insert. And that's all for this particular episode. So in this section, we're going to work on cursor invalidation with Dbms stats. With Dbms stats, gather table stats, you can pass a parameter called noInvalidate. NoInvalidate is a Boolean, so you can pass true, false, or take the default, which is null, and that's considered auto-invalidate. And what we're going to look at is what happens to the cursors when we choose any of these three options. So the first thing we're going to do is create a table. And let's run a query against the table. Let's find out what that SQL ID is by looking at the explain plan. Here's the SQL ID. Notice it's a full table scan. Let's look at the number of executions in $SQL. So in fact, so the number of executions is 1, but let's run it a second time. So now we should see counter set to 2. So now we have 2 executions. So let's see what happens when we set noInvalidate, and in this case I'm going to change noInvalidate equals false to start with. And let's see what happens to $SQL counters. Well, nothing, but we see that the invalidations is set to 1. So if we do a subsequent query, we'll see that our counters are reset back to the beginning. So let's take a look at that. So we can see the child cursor is set back to 0, which was already there, but the executions and parse calls were set back to 1. These two columns are historical, so yes, we've seen some loads and invalidations in the past, but these parameters have been reset. Okay, let's clear up what we've done. Share. All right, so let's see what happens when we set no invalidation equals true. First of all, let's run our query. In fact, let's run it twice. And let's see what happens with $SQL. So we've run 2 executions. So now let's see what happens. No invalidate equals true. So that means don't invalidate. So we're not going to invalidate. Let's see what happens here. Notice that the invalidation flag has not been set. And in these subsequent queries we run, just update the counters. No invalidation. Okay, so that's interesting, but what happens when we either flush this particular query or flush the shared pool? So let's go and just for fun, let's flush the shared pool. System flush shared pool. Now let's run the query. Now let's look at $SQL. Okay, now it's considered an invalidation because we've finally reset. We've done the invalidation at this point. We said hold off on doing any invalidation until this is flushed out and the query comes back. So now we recorded an invalidation. Okay, let's take a look at the last option. The last option is to take the default, which is null, or auto invalidate. Now this is a trickier thing to test because with auto invalidate, the query does invalidate after an invalidation period. The invalidation period is a hidden init.aura parameter. So let's take a look at that actually. Currently, the invalidation period is set to 18,000, which is seconds, which is 5 hours. So we're going to shorten that for this particular exercise. So the first thing is let's clean up what we've done. Let's go ahead and change the invalidation period to 5 minutes. And actually, let's run our query twice. Okay, so we're back to where we were. And let's set timing on. Let's go ahead and run our Dbms stats, but this time we're going to take the default, which is auto invalidation. Okay, so we have done this at 9:08, so let's go add 6 minutes to that. The first thing is let's take a look and see what happens to $SQL immediately after. And no changes. Also, let's run a query. And you can see that the counters have been increased by 1, but no changes yet. But now we're going to go and wait 6 minutes after this and see what happens. So we'll probably speed through this part. Okay, so it looks like we've spent enough time here now. So now let's just run this particular query now. See if anything has happened. So no invalidation has taken place just yet, but let's run another query now that the 5 minutes has taken place. And check $SQL. So now we see a new child cursor has been created. And so the old cursor is done, and a new child cursor has been created. Notice the invalidation flag hasn't been set, but let's look at $SQL shared cursor and see what happens there. Okay, so we see two child cursors, and we see all of these flags are set to no. Notice that now it says for the first child cursor of 0, it says the rolling invalidate window. And also notice for child cursor 1, we see all these flags are set to no except for this one. And this one is the, what value is that? That is the roll invalidate action mismatch flag. So it has been set because there was a rolling invalidate that's occurred. And that's it for this section. So in this particular episode, we're going to talk about deferred or pending optimizer stats. So we can try on new statistics, try them for size. If we like them, we can publish them. And then if we don't like them, we can actually delete them. So I'm going to show you how that is done. The first thing I'm going to do is I'm going to run a query on the sales table. So let's take a look at that. And let's look at the explain plan. So currently the explain plan is a full table scan. This particular query does a full table scan. But let's say we're going to take some new statistics, and that potentially could change this explain plan for the better or for the worse. And so for now, let's defer the publishing of these statistics to later to see how do some what-if analysis. So the first thing I'm going to do is look at the current preferences. Okay, so the current preference here for the sales table is to publish statistics. So I'm going to actually turn that off. And let's validate that. Okay, so now the publishing has been turned off. Now let's look at the current statistics. So the current statistics was based on something that we had done today at 1351. But let's look at the pending statistics. Now let's gather some statistics. So now we see there's no pending statistics, and we've turned the publishing turned off. Let's gather some statistics. Now let's check the analyze date. Notice that the last analyzed date in DBA tables hasn't changed because we turned publish off. Now let's look at the pending stats. We can see now the pending stats tables, and there's multiples of them. There's DBA pending stats. There is DBA column pending stats. And there's also DBA tab histogram pending stats. So let's run the query again and see the explain plan. We're still doing a full table scan because we've not published the new statistics, but we can do something about that. There is a parameter called optimizer use pending stats, which is turned to false. So let's go ahead and turn it on temporarily and validate that. Now let's run our query and see what happens. And let's look at the explain plan. Now it uses a bitmap. And this is the new statistics that are pending but not yet published. So if we're happy with this, then we can go ahead and publish these statistics, and this is how we do that. Okay, now it's published. Now let's look at the last analyzed date of DBA tables. Now we can see that the time stamp has now changed for the last analyzed date for the table sales. And let's look at the pending stats tables. They're all empty because we've published these pending stats. Let's go ahead and turn off not using pending stats. We're doing some cleanup here. And let's go ahead and turn on publishing the statistics again and validate. Okay, so what we can see is that we don't have to accept the statistics and gamble with any changes. We can actually defer the publishing of the statistics, look at it. If we like it, then we can go ahead and publish it. And that's what we've demonstrated here.